Welcome everyone. And so hopefully a few more trickle in here, but tonight we're welcoming Norman Staub. He graduated this year in spring 22 from IC. And Norman, did I misquote your major there? I think I quoted as cinema. Are you EM or cinema?
Oh yeah, I'm emerging media.
Okay.
I missed that. Sorry.
Sorry, my bad. But an emerging media student from Ithaca College, excellent student. I took a couple of my classes, really enjoyed having him in every class he was in. And he's going to talk a little bit tonight about being a technical artist and working in virtual production and some other areas. So I'm going to go ahead and hand it over to Norman. And then I'm sure he'll open it up for questions after or during or however he wants to do it.
Cool. Yeah, thank you, Brad. And thanks everyone for joining. It's nice to see so many people in this call at such an ungodly hour. I don't have necessarily like a presentation that I'm going to go through for this. I kind of just want to show you guys what I worked on last semester and a little bit more, and sort of tell you my process for doing that. For my senior emerging media capstone project, my partner Adam Thacker and I, he graduated in my class as well, same major. We decided that we wanted to pursue building a virtual production studio. And this wasn't really something that we had just decided to do out of the blue. For our junior capstone project a year previous, we had developed an iPhone app to allow a user to use their iPhone and AR kit to essentially record like a video, but record motion capture data, which could then be fed into Blender, the 3D software, to create a virtual camera sort of based off your mocap data. That was super rough. I don't have a great demo to show you guys, but that is to say that we had sort of started this virtual production task earlier for our junior project, and it was super small scale, pretty basic, but that had sort of clued us into the fact that virtual production is really probably going to take over the visual effects industry for a large majority of the work that's happening in TV and film. Just because with how fast computers have gotten these days, why not do something in real time if you can? So whether that's capturing motion capture data rather than hand keying a camera, or using something like Unreal for production purposes rather than video games. To start out with this virtual production project for our senior capstone, we kind of we're starting at square one, because there obviously wasn't a virtual production sort of space for us to use. What we ended up doing was linking up with Nigel Martin, I believe his title is the technical operations director. Yep. Okay. So he's kind of in charge of managing purchasing new equipment for the school, sort of outside the domain of PPEX. So that's our for non-IC people, that's our equipment center, where students can check out cameras and that kind of thing. Nigel handles a lot of pretty much everything, all the new technology purchases that are serving the infrastructure of the school itself and the facilities that students have access to. So he manages a lot to do with the studio spaces in the park. So it turns out when we had approached him that he was sort of looking into virtual production to develop that for the school as well. But he, with all the stuff that he has to do, he didn't really have too much time to sink into figuring out how to kind of make all the pieces work together and figure out what we need and what we really don't. So Adam and I decided to take that task on for our senior project. And I can link you guys to my website here, drop a little link in the chat, and you can check out what we ended up building for our virtual production studio. If anyone would like me to share my screen with that website, just let me know.
Yeah, you might want to do that.
Cool. Cool, yeah. So forgive my web design. It's kind of bad. But what we ended up doing was, I was also the student director of Park Productions, which gave me access to some equipment that would have been hard to get for the long term from somewhere like PPEX. I'm sure that could be worked out, but what we ended up doing was using Park Productions cinema camera because we knew the schedule that camera was needed on other projects for. So we were confident that we could kit it out and use it in the space without issue for an extended period of time over the semester. And so to run through the basics of how virtual production works, and not all virtual production, but this specific sort of build that we had of it. So essentially what you need to have, if you want to have a green screen set or something like the volume with LED walls, you can't just do something like project the backdrop that you want onto those green screen walls or LED walls without any information from the camera, because that image will stay locked in place as soon as you pick up the camera and start moving it around. So what you need to do to have a realistic moving backdrop, sorry, and you can see that sort of fully in action here. So our goal was kind of to be able to have a fully handheld camera without really any sort of stabilization and have a background tracked with parallax working and everything with a green screen composited subject over that background. So working backwards from that goal, we started by identifying a tracking solution that we'd need. So what we ended up deciding on was the HTC Vive hardware, which works through Steam VR. This is a good solution for us because of the relatively low cost and ease of implementation into our existing setup, because we both like video games. So we were kind of familiar with that environment already. So we started this by just reaching out to Ed Schneider, who's the innovation lab director at Park. He has some classes, some focused around emerging media, motion graphics, that kind of thing. If you've ever talked to Ed, he's like super into this new technology. He's always got some project going on in his innovation lab, and I highly recommend you work with him if you don't know who he is, or reach out to him, because he's just a great professor to know. He's very enthusiastic. But he had a HTC Vive kit, so just the VR kit, and that is a head-mounted display tethered to a computer with 2 tracked motion controllers, and all that hardware. So the head-mounted display and the controllers are tracked through 2 what are called base stations, which essentially emit a infrared pulse at a regular speed. And then all of these things, so the headset and the controllers, have a bunch of small infrared cameras that are able to sort of see where these base stations are in space and differentiate between them, and then sort of from that reverse calculate their position in 3D space, all relative to each other in the room. So good for VR, also good for virtual production, because what the key in virtual production is to getting something like that appears like this, where you have a camera that's able to hold up relatively well, tracking around a subject. You need to know the exact position of that camera in space, So we decided to use VR hardware for this. Our V1 was basically a set, like a shoulder rig, just with the shoulder pad and the two handles, and we taped a VR controller to the top of that, and we managed to get that tracking in real time within Unreal Engine. So there was no, that was our version 1, so there was no camera involved. We basically just wanted to be able to hold a virtual camera and move it around in real time and see the results of that. So that was it was successful for the experiment, but it certainly wasn't usable in a production setting because that was done entirely within Unreal. And for those of you who have used Unreal, it's not that easy to get it to do what you want a lot of the time, unless you sink hours and hours and hours into it with all your blueprint structures and all your nice file management. So what we decided to do on Nigel Martin's suggestion, he had been taking a look at this software called Aximmetry, which is mainly made for broadcast, live broadcast. But what it's really good at doing is basically handling all of the tracking and compositing that you need to do for virtual production, handling all of that with pre-built Unreal blueprints and all this great stuff, live link to Unreal. It basically takes all that and handles it for you with a ton less setup than you would need to do by hand in Unreal. So once we had started using Aximmetry, we had really kind of cracked the code to making progress on this, because before that point, we were kind of just spinning our tires, banging our heads against our keyboards, trying to use Unreal, which was really difficult. And I'm sure we could have eventually made Unreal work, but especially for a semester-long project, it really wasn't realistic for us to go from 0 to production ready entirely within Unreal. Again, if you've used Unreal, you'll understand this. So Aximmetry really made our lives easier. And that's not to say that Aximmetry does everything for you. It certainly doesn't. There is a big learning process involved with Aximmetry. Specifically in the calibration of cameras or lenses rather, with their virtual camera counterparts. So what you can see here in this, so you see the camera moving there, you see that represented here. What you're seeing here is Aximmetry gives you a virtual studio, sort of a representation of your studio, which allows you to set the wall positions. And this is all fully tracked with your VR hardware. So moving around, and sorry, I should have mentioned this. So to track a camera in space, we're essentially using this Vive. It's called a Vive Puck, I believe. It's basically a VR controller without the controller. So all it is just to basically track a point in space. So you can use your VR hardware to track whatever you want. It's easy to mount on stuff. So we threw it on top of a camera, and that let us know exactly what the position and rotation of that camera was at all times. So here you can see this lines up pretty well. And what a lot of our time was spent doing was sort of calibrating the lens, which you need to match basically all of the parameters you can between your virtual camera and your real life camera. Otherwise, things start sliding around and illusion falls apart pretty quickly. So
Norman, just one thing. I'm taking a Become CG Pro class, actually shadowing Nigel right now. And one of the participants in the course is I think lead tech artist, runs the studio for Honda in Dallas. and they have a building out a virtual production set. And he basically said the same thing, that they were really making slow progress working directly in Unreal, and that they had a big shoot coming up and they leaned on Aximetry, and he said it was like a lifesaver because it's kind of packaged together. What were kind of some of the struggles that you ran into in Unreal that kind of pushed you in that direction?
Yeah, no, I definitely agree. Aximetry was a lifesaver. And again, not because it made our job seamless. You still have to do a lot of work within Aximetry, of course, but kind of the main things that it remedies are, so in production, you really need, and I'm sure as you all know this, your once you get on set, if the equipment that you bring to set to record what you're there to record, if that doesn't work like immediately and reliably, then you're kind of screwed and you're kind of just lighting money on fire. So if you get all your actors on set and Unreal is like taking an hour to boot, or like you're digging through this like nest of blueprints, which for those who don't know what blueprints are in Unreal, they're basically a visual coding language. So with typed code, you have your classes and your functions, and it's all sort of formatted with tabs and characters and whatever. Blueprints are an easier, more like visual way of coding things. So they're basically like blocks. If you've used Blender, nodes are the same as blueprints. So in Unreal, those blueprint structures can they're insane. Like if you're doing something sufficiently complicated, like as complicated as even nowhere near as complicated as developing a production ready virtual production solution, even if you're making like the most basic platformer ever, it's like you need months and months and months of familiarity with Unreal, and the UI of Unreal, maybe I just didn't take to it as well as others, but the user interface in Unreal and just the user experience is just awful. Nothing's where you think it should be. There's all this stuff that like you're supposed to just know like implicitly when you open the program, and then like you realize you don't know anything once you start trying to do something. So
it's weird from coming from a 3D package too, because you're a Blender person. Definitely, you know your way around Blender really well. I'm coming from Maya, and there's a serious disconnect from a normal CG production software going into Unreal because it's set up for game development. It's a whole different paradigm. So it's not really like made for production yet. It's very game oriented.
Yeah, that's true. Until the last couple of years, game development tools and CG tools have been developed on like parallel but entirely separate sort of streams of pipelines and workflows and all this stuff. So like someone working in CG for their career, most likely until a few years ago, most likely has never stepped foot inside of a game development studio.
Yeah, very true.
So like there was until recently, until you're able to process and render photoreal environments in real time with game dev engines. Until that happened only a couple years ago, like there was no even reason to think about using game technology in film, aside from the most basic level. So all that is to say, Unreal is not built. It's simply not built for doing things in real time like a production requires you to. So like move that brick over there, change that, do this, okay, roll. That's like really hard to do in Unreal because games are and in Unreal too, as I've experienced, like games aren't like that, where you can pause the game, go into your editor, move around stuff, change logic. hit play. Like games, you have to recompile everything every time you want to change something about your game. And this is probably kind of incorrect. I'm not an experienced game developer by any means. This is just my experience coming from working in CG packages that allow you to do stuff a little more easily. But games are designed, and game engines are designed to build extremely efficient games that can run on the lowest hardware specs possible. So to do that, you need to take a lot of time in your game development tool to kind of build these games and compile them down to something that is easily executed by a number of different machines. With CG tools, that doesn't really matter. You don't need to hit play and see a full fluid image looking super nice and glare and lens flares happening in front of you. Like CG tools are designed to, you hit render and then, okay, see you next week. That's kind of like CG tools. They have this kind of, you're expected to, so this is kind of a tangent. I just want to say that CG tools and game development tools are very different. And that's why it's hard to use Unreal as a essentially a CG tool or production tool, because it's just not built to do that. So Aximetry helps this because they will deal with the problems in Unreal for you. And they already kind of have. They've built a fully featured tool set to alleviate a lot of the issues that come with using game development technology in film in a production setting. Super reliable, never crashed on me once. There's so many things I didn't even delve into that I know would be super valuable in a production setting. So yeah, Aximetry is super good. I guess, so I've just talked a lot. I've dumped a lot on you guys. Are there any questions so far, maybe?
Just one quick thing on Aximetry. They have a specific packaged version of Unreal that you install alongside Aximetry. So I think that's one of the kind of production ready strengths of it, is it already has this vetted engine that's customized and made to work directly with Aximetry. The option I found of being able to both build and compile, an efficient build of the scene, or to work relatively real time back and forth from the engine, make modifications, and then run it in Aximetry. It was really flexible too. And like you said, Norman, it didn't kind of crash on me like Unreal like constantly crashes on me. And that's one thing I thought, like Maya was bad, but Unreal is like driving me up a wall. Definitely.
Yeah. But yeah, so does anyone have any thoughts or questions maybe so far in this discussion?
I have a quick question. I was thinking about what you said about the camera and the production that you were trying to achieve as a VR project. I feel like I'm still confused at what kind of like material you've been using and how you kind of like, adjusted together, because I think like several weeks ago, I had a training on some sort of like a Canon camera that they brought for the higher education. They use like AI technology on it that they can recognize the face and can take a picture, and there's lots of like features. So I was trying to like imagine something like that, but yeah, I feel like that I'm confused in what you were doing it.
I think I know what you're getting at. So the camera, we used a nice camera with a lot of features. Sure, that's cool. But the camera really doesn't matter. And I know that's a cliche, like for film students, like, oh, gear doesn't matter. Just no, but that's not what I mean. So all we used from the camera was, first of all, it was nice that it was a cinema camera, because that meant we had really fine control over every parameter that we needed to have control over. So we were able to set manual everything. So solid white balance. We knew that. We had the shutter speed. We knew that. Aperture, all this stuff. No autofocus. I hate autofocus. And so all we really took from the camera was a video out. Our camera specifically only had an HDMI out, which is kind of annoying. Usually like an SDI is nice for a studio setting because it's just better. But basically the only important thing that we needed to get from the camera was the video signal live. So, and that's a clean video signal too. So no gizmos like you're talking about, no autofocus face tracking, no focus peaking, no zebras. All we wanted from the camera was the image with no stuttering, no anything. We just wanted the clean image as it came straight out of the camera. We didn't even have it in 4K or anything. The camera was shooting in 6K, but the image was only in 1080 that we were getting live. So how we were able to use that to achieve like a decent virtual production setup was the big sort of crux of this project, which I should have mentioned a little bit earlier, was the capture card. Capture card is necessary for this kind of work because you need to get that signal, that video signal from whatever you're using to shoot. You need to get that into your computer processing. You need to have a digital representation of that image signal. So just taking an HDMI cable out of a computer and plugging it into another computer's HDMI port, that's like, no, that's, so HDMI coming out of like a computer is kind of a one directional thing. You need a specific technology to basically accept that signal and turn it into something that's workable, unless it's like a monitor or something. So essentially a capture card, we used a Blackmagic capture card. What that lets you do is take that video signal and put it into your computer and then use it in processing. So whether you want to have that image be used in Unreal or Ximetry, it's basically just delivering that video signal as a digital. It's almost like turning any camera into a webcam, essentially, because a webcam will let you take that video and it'll let you do fancy things, add effects, do whatever processing on your computer. Capture card it's just a fancy version of that. It just gives you options. Like it lets you process that video signal in whatever way you need to. So what you see here, the background, the virtual space is tracking to that image accurately, not because the image really plays any factor into how well that tracks. It's because all of the parameters of the virtual camera, which take away the chair, take away the floor. The virtual camera is essentially seeing this grid of tiles and these two posts. The virtual camera needs to be, again, as close as possible to the real camera in terms of things like lens distortion, and then you just get into all the things that make images from cameras look the way that they do. And this is all being tracked in real time to look like it's part of to look like they're sort of meshed together, this real plate and then this virtual plate. They look like they're one because of this VR motion tracking, which is allowing us. So think of this VR tracker on top of the camera here. Think of that as another camera entirely, overlaid onto this real camera in VR. Does that make sense? That's kind of the best way I can explain it.
It does definitely, yeah.
So Norman, I wanted to mention something about the capture card, because in your V1 example that you discussed, is essentially a virtual camera example, where you could, if you don't need the real-time compositing, which helps in a lot of ways, certainly, especially for calibration, that definitely helps. But if you can get it dialed in with some approximate values, you can still record in the camera and track the motion of the camera and composite those things after the fact. So you could do tests without a dedicated capture card to start, but actually getting a fine track and getting things a composite that's nice and clean definitely requires a capture card. Norman, you noticed, right, that the tracking data comes in much faster than the video data usually. Is that the case?
Right. Yeah. So yes, the video signal had a larger amount of delay for sure. So that's another reason why Ximetry was so groundbreaking in our progress with this. Is it made it really easy to us to synchronize those latencies. So basically all we needed to do was type in a number value, like a float, so a decimal number inside of Ximetry, and just 2 boxes. So you had your camera latency and you had your tracking latency, or whatever it is for the motion trackers. And you basically just mess with those values until you can move the camera and both images look like they're moving at the same time. And that's another thing that was kind of fun with this project, which there's probably more scientific and precise ways to do it. But the way that we ended up doing it most of the time, because it worked, was just having one of us move the camera, move it around, pan it around, whip it around, like do all this stuff. And then the other person would just sit at the computer and just fine tune those values until we basically drive the difference in those images to 0. So it was actually a very manual process. Not to say that it was like difficult or super like scientific or involved or anything. It was just basically looking at an image and saying like, oh, that looks weird. Like, why does that look weird? Oh, it's probably the latency. No, it's probably the focal distance. And then you just mess around with that until you get a good feel for it. Cool. Yeah, so anybody else?
Yeah, Gabby.
Yeah, hi. So I had a question. Earlier you were talking about that you created the app. There's a lot of great information, but it's a lot being thrown at me. But is Ximetry, is that the app or that's the software?
No, so the app is a bit unrelated. That was sort of our dipping our toes into virtual production. So the app was super bare bones. It's not on the App Store. You can't find it. It sucks. Like, you shouldn't want it. If you do want an app that does something similar but well, check out VirtueCam. I'll type that into the Zoom chat.
You need a LiDAR iPhone or iPad though with that, right?
I don't think so. I think it works
Okay.
with ARKit, which is that should work with everything.
Nice.
But
Probably like accelerometer, gyroscope based stuff. For
yeah,
like
yeah.
actual like positional stuff, I think it still needs LiDAR.
No. ARKit is that's been around since before LiDAR stuff, and that's just Apple's their own sort of black box library that lets you use your camera to get that position on rotation information. So that's used for any sort of AR app that you use on your iPhone. Most of that is funneled through AR. So like Snapchat or Instagram, when you have those filters that like you put a sticker, like a skeleton on the floor, and you move your camera around, that's using ARKit too. So Apple makes it super easy to I say that, but Adam had a really hard time with that, and I would have as well. But yeah, so it's basically a library, like a code library that you can call functions of and sort of use for your own work.
And so it's using computer vision, just landmarks within the field of view of the camera.
Yeah.
So the app is supposed to, I guess, scan like the area or your setup essentially, correct?
The app was. You're giving us way too much credit. The app was like really bad, and it didn't really do much. So all the app did was forget the video. Like, you're recording, you're moving around like you're recording a video, but it's not actually recording video. it's recording into a text file. We use text files. It's recording position matrix and a rotation matrix onto like a line. So you have your position value. So that could be represented by 3 zeros, say. So that's like your 0 position. You move left 1 meter, and then you have like 0, 1, 0 or something like that. And then rotation, the same thing, but a little more complicated. So like you can imagine these values changing for like, you can basically set a poll rate that you want to get this information from ARKit and then write it into your text file. I think we did it at like 60 frames per second or something. It's like 60 times per second. So basically that's 60 lines of coordinates a second. So 60 times every second, you're updating the position and rotation of a point in space. And then within Blender, I kind of reverse engineered those numbers to represent the actual movement of the phone. So it was just a text file, and all you were left with at the end of it was a virtual camera in Blender that moved sort of like you moved your iPhone. Does that make sense?
Yeah, that's cool. I was gonna ask a follow up on that. So if let's say you got an investor, where, I guess if you had the chance to work on it more, where do you see the app going, and like for what audience, for what purpose? Is it like make live stream easier, make people have more, I guess, streamlined virtual setups so it's more interactive? Like where do you, if you were able to develop it, where do you see that going?
So yeah, kind of at the same time that we were developing this app, someone made they made Virtu Cam, which what I mentioned before, that's just VIRTU CAM. And that lets you do everything I just said, but with so much more control over it. You can control camera parameters like your focal distance, stabilization, and you have real time that you basically can see your Blender viewport or Maya viewport on your phone as you're moving it around. So it's almost like a viewfinder, like a virtual reality viewfinder into your 3D software. So someone already made this, and that app is like, it's so cool. And if I somehow got an investor for that app and this other Virtu Cam hadn't been made, that's like what I imagine it would be like. It would be moving towards if I had to put more development into it. But we both had like a really hard time with app development, and it just wasn't for us. So we kind of like, we managed to have a functional sort of thing by the end of it, but it wasn't something that we were too interested in continuing, specifically with app development and that kind of thing. So we decided that virtual production in a more like studio focused context, like we did for our senior project, was kind of where we wanted to go.
Norman, I posted a link. I couldn't find Virtu Cam specifically. Virtu Camera, that's the one with the Blender and Maya plugins, right? Is the one you're talking about?
Oh, right. Yeah, that's it.
Yeah. Okay. So yeah, the link's in the chat. But yeah, quick virtual camera setups are a good way to jump into kind of that AR space that's adjacent to virtual production. Doing kind of fully 3D films and being able to use interactive cameras, tangible devices to pose as cameras in your set is really cool. And it gives it Norm, the camera work that you were doing in my 3D animation class was
pull up them right here. So like, yeah, this was just part of a short character animation project, but I think probably my favorite part of it, the part that I think turned out the best, was the camera motion. And I come from like live action film production. That was what I did before I wanted to do visual effects. And with that, I'm a very lazy live action filmmaker. So handheld was always my go-to. I hate tripods. So I kind of became really familiar with the sort of dynamics of how a camera moves and how to get interesting shots just holding a camera with your hands. And you can see it really brings it to life more than this project would if all of these shots were at the same angle but locked off and not moving at all. So yeah, I think using this kind of virtual camera stuff is a great way to add realism and character to 3D work. Not to say that you should skimp on other parts like maybe I did sometimes, but yeah. Any more questions, comments?
I do have something else too.
Sure.
So I do I'm doing live streaming now because I'm a DJ, but I'm always looking for like different ways I guess people can interact. So for something like the different cameras that you were talking about for more like AR, I guess, integration, do people then have to have like their own version of the app or something like that? Because I know there's one for Adobe, but then people have to have their own downloaded version of the software as well. But do you recommend like any, I guess, apps that can have people, I guess, engage with each other, like you know, like an activity or something like that, besides what's already on, say, like YouTube or Twitch like platform?
I apologize. That's just really not an area that I know too much about. You're sort of getting into like you said, like live streaming, and that sounds a lot sort of like sort of live social space video game type stuff. I think all that stuff is really interesting. I'm definitely sort of following the development of that, but I'm sorry, I'm just really not the person to ask about that.
No worries. Or if anyone else, I guess, on this call has any ideas too. I don't know. Just wanted to see.
But I think it speaks to the overlap that's happening too between like these tool sets that Norman's using them for production, something that's going to be time-based and in the can and packaged, whereas many of the technologies he's using are real-time technologies that you'd use in something like live streaming. And Gabby, are you taking a live event class with Chrissy this semester? Yeah, so she's already bending my ear about virtual production and working with the theater department and what they can do with kind of immediate kind of live effects and backgrounds and stuff that are dynamic and changing within production. So, I mean, there's a lot of overlap, and these tools kind of both work in real-time app development, but then Norman's kind of using them for virtual production. I'm wondering, Norman, you mentioned to me that you've been doing, and I know that when in my 3D class you mentioned this too, photogrammetry work, and that's kind of what kind of got you clued you into this job that you're working at now. I know you can't like talk much about it because it's you're under a numerous NDAs, I'm sure. But do you want to kind of mention, because that's another kind of interesting field where you're using tangible, physical, real world interaction to then get a digital artifact kind of easily from that. So can you maybe describe that process and some of the tools you use for that?
Yeah, definitely. Yeah. So, and this is another, I think, a good point to touch on. Looking for jobs. I was looking for jobs, and I heard nothing back. Basically, I applied to like 20 or 30 visual effects positions at companies that you've heard of, and I didn't get a single email back or interview or anything with any of the VFX companies that I was looking at. And like that was super demotivating, because I had spent so much time at IC and I built up what I thought was a decent resume for just graduating, and I thought I'd be able to like snatch something up like no problem. But that really wasn't the case. Like, it's tough out here. I have a lot of friends who are still having a great difficulty finding jobs, and that's just the way of the world. So eventually what I ended up doing was expanding my search a little bit. So for background, I'm in the greater Boston area. So there's not a whole lot of film or visual effects. Certainly, there's not a whole lot out here. There's a little bit, but really nothing close to New York or LA or anything like that. So I was looking for jobs, kind of bummed out, hadn't heard anything, and I decided like, oh, let me expand my search a little bit, like photogrammetry artist. Because I had done a few sort of tests and experiments, and I thought that it was something that I could at least apply for, even if I didn't have any professional or extensive experience in that. And sort of what got me into that was, actually, you can see it on my page here. There's neural radiance fields. So essentially volumetric reconstructed video synthesis, like cool stuff. So kind of to give a quick demo, this is sort of a new method of I guess you could call it photogrammetry, which is creating real or creating a virtual object that is a representation of the real object through a number of different camera poses and images and that kind of thing. So what neural radiance fields do that's really cool is that it's actually not a mesh. It's not a mesh with polygons like triangles or squares. It's a volume. So what you're seeing here, this is actually it's almost like a point cloud, if you know what that is. So it's a very dense collection of points with a certain color, or in this case, radiance. So those areas of the volume have different color properties as you change camera position, as something does in real life. This is like how reflections work. So if you're looking at a piece of metal or something, it's like shiny from one side, and then you move over and it's not shiny anymore. This is kind of what neural radiance fields, newer technology, it's kind of able to replicate. So you see sort of, if you look at the detail on the engine block here, you can see this sort of reflection coming through as you rotate around the object. And that's completely automatic with this process. That's not something I needed to do by hand, making textures or anything. And I encourage you guys to look up more about neural radiance fields, because I think it's a super interesting topic. But creating a couple quick demos like this, just in my sort of off time when I was still living in Ithaca, I thought I sort of had these in my back pocket, and I was looking for jobs, and I included photogrammetry jobs in my search, and I found this. I got an interview with this place, Neo Cybernetica, which is where I work now. They're a cybernetics company working on building general intelligence for autonomous vehicles. So it's like really, really cool, interesting stuff. But I basically got this job because I made a couple quick demos in like a few hours, like a couple weeks before that by coincidence. So like, they didn't expect me to be a professional photogrammetrist or anything like that. They kind of saw that I had an interest in visual effects. Generally, I could prove myself as a visual effects generalist, making environments and whatnot. And I'd also shown some interest and put together some demos using this newer technology that they're also sort of looking into using in simulation. And I basically got this job with not a whole lot of experience, like no professional experience outside of college, because I was interested in like learning how to use cool stuff hands-on. And this is all freely available technology. You just go to the GitHub page for, at least this one is the one that I use, NVIDIA Instant NGP, if you're interested. But so that's to say, like, I became employed, like happily employed so far, by basically pure coincidence, but also because I was doing, like, interested in learning and applying this stuff in my spare time. So I think that's super important for you guys. If you want to find a job in this field, especially with how fast it's advancing right now with virtual production, like we looked at, and all this other stuff. If you want to get a job, you don't need to have 10 years of experience on set. You need to prove yourself as someone who's willing and excited to learn about new technology. You don't have to know everything. You just have to show yourself as someone who is interested and capable of learning this stuff, which is very doable. So I think that's just something that maybe not a lot of people prioritize. Like I did. I prioritized this whole web page of like crap, basically, because I thought that's what was going to get me a job, but it turned out it was like the thing that I spent the least time on, that I just thought was cool. So yeah.
Yeah, and the fact that you have it visible and out there, when you make a test, you put it and it looks cool and it's something interesting, you make a little page on your website and show it off, or social media, or however you're going to show that off. But it's important to get those tests out there. It can be short, it can be fun, it can be a one-off, but get it visible.
Definitely. Yeah, I mean, just to briefly go into photogrammetry, I was hired as an environmental technical artist. So my role is to build virtual environments with real world items, through gathering them through photogrammetry, and some stuff that I use for that. And then technical artist being implementing those that sort of, in my case, implementing those environments into usable format for simulation and this kind of thing, implementing them through code. And so there's a little bit of like computer science involved with that too, which is also good. I recommend taking some computer science classes, especially if you're interested in visual effects. Like, they will be valuable. Like, you'll know a little bit more about what's going on behind the scenes, which it's kind of impossible to know everything. But the more you can know, the more you sort of have an insight into why After Effects froze. But yeah, so yeah, photogrammetry, I use reality capture right now. I'm getting a little fed up with it, but I think it's still really good. And I'm going to be using Blender for processing, sculpting of those photogrammetry models and that kind of thing. And then we are using Isaac Sim for our simulations, which is it's built by NVIDIA. It's sort of on the come up, being used in engineering and this kind of thing. Look into it, because I don't know much about it. But yeah.
I'm trying to learn Houdini for Sims right now. It's just too much.
That's a fun afternoon.
Yeah. Polycam's really cool. It's a nice quick one if you have an iPhone or iPad to jump in. I mean, it's really cool. I'd not seen this neural radiance field technology specifically. So it's essentially capturing material properties within the photogrammetry.
Yeah, almost purely by accident too, because all it's trying to do is take your input images and blend between them. So that kind of just for free, that comes with the material properties that you're looking for, which is really cool.
Yeah, really cool. That's what my main gripe about photogrammetry has been, is like, it looks great. Now I got to really generate a spec map to make that look halfway decent. Yeah. Cool. Any other questions?
Well, yeah, that's kind of all I've got.
Thanks, Norman. That was awesome. Very informative. Golf clap. Cool.
Thank you guys for being patient.
I think there were some questions
Oh yeah.
in the chat.
In the
Please,
chat.
please. Oh, in the chat. Oh.
Kiki wanted to know if I assume if she wants to go into VFX, do you recommend getting a master's in computer science?
No, don't get a master's.
Shannon might take offense to that.
Sorry. Okay.
I don't
They're
have
very
a
important.
VFX master's
People with
program.
masters-
I know.
People with master's degrees in computer science, of course, they're important in visual effects. Like, we need those people. I would not be able to, like, we need those people. Like, we need them somewhere. So I guess what areas in visual effects are you more interested in that lead you to want to go the way of master's degree?
Honestly, it's vast. I mean, I'm right now very interested in just pursuing VFX art, but like in terms of AI technology developing and everything, I almost like to think of it as like, you know, in Charlie and the Chocolate Factory, when like the dad gets put out of work, but then he gets a job building the machines. Like, I know that's a weird example, but like I kind of can foresee like it being helpful in like a, I don't know, not so distant future, I guess. But I'm just wondering if like in terms of thinking like in 10 or 20 years or so, if it would be wise to kind of understand the softwares and know how they work so that, you know, we would never be at risk for unemployment.
I think if you're talking about that large of a time scale, I think by that point there will be, this is all speculation, but I don't think much of anything that will be I don't think that will help you in 10 to 20 years, I guess. I'm sorry. I don't have a good answer for that question.
No, it's fine. I don't know. I read an article and it's just been in the back of my head. I'm like, maybe that's a good idea, but I don't know. Thank you.
So no, but like, are there, I guess if you're not sure, it's hard to say, but I think it's really all about where you want to end up in visual effects. If you want to be an artist, then some knowledge of computer science will help you, sure. But that's not where you're going to be spending your time and effort. So if you want to be purely involved in the artistry of it, technology is getting better and better. You need to worry less and less about the sort of computer back end of everything. And while it's certainly helpful to know about that stuff, I don't think it's extremely necessary, unless you want to have a career in that area of like very extremely technical sort of back end computer stuff for visual effects. But no, I don't think it's necessary. And this, I don't know anything, like, so I don't know. I'm not the best person to ask, I guess.
But I think your intuition of like, hey, in 20 years,
Something's
who
gonna
knows?
change.
Yeah. One trend you can really track though, as far as like development of artist tools, especially when related to computer artist tools, is that as processing power increases, the cost of that decreases, and just understanding of the software developing and improving, artists are just expected to do more. And so learning new tools, I think, is really important. But think of AI and the stuff also that Norman was talking about here. Think of those as tools that have interesting possibilities, and you should kind of like be aware of those tools. But to really know, like, do I know how to assemble a brush, a paintbrush from bristles or whatever? No, but I still know how to use one. AI is not going away, and it's certainly going to affect everybody's industry, artists especially. Just learn it and learn how to use it. Computer science background helps if you're going 3D, certainly. So if you're going to go visual effects, 3D heavy, and what Norman is kind of doing now as a technical artist, that is a job that is defined by bridging the artistic aesthetic side of things with the technical and being able to talk both languages. And those people are really in demand. So it's not a bad thing to learn at least a little computer science. A graduate degree in it, if you really wanted to go into that, definitely.
Yeah, definitely. I agree completely. I think it's important to have that enough knowledge to where you can sort of understand in a general sense what's going on behind the scenes. But yeah, unless you want to be spending your time specifically working on very advanced problems related to what you got your master's in. If you just want to be an artist in visual effects, then I don't think there's a need to, that's probably a waste of your time if that's what you want to go into.
Cool. Thank you guys so much. I appreciate it.
Hey, Norman, I know you don't come to these meetings that often, but if anyone was interested in talking to you after this, what would be the best way for them to contact you?
Oh yeah, absolutely. You can email me here. I'll type it in. That's my Gmail. Comes up on my phone. Yeah, I'll reply to that.
And if you have trouble getting in contact, I can track them down, certainly.
Oh yeah, my phone just broke at so yeah. Yeah.
The iPhone that you made the app with after you got the LiDAR iPhone, right?
Yeah.
That's unfortunate. Left it plugged into a
DJI.
DJI controller, yeah.
It's bricked. I left it plugged in. I walked away for a second. It's fully bricked. DJI, don't trust them.
I was just about to get mine up and running again. Now I'm scared to even plug my phone in. Thanks. Cool. Well, I'll stick around for a little bit. And thanks again, Norman. That was great. Very informative.
Sure.